Okay, so welcome back, and now what we're going to do is we're going to do an example of dealing with a side-side angle. And in this case, we have these two sides and this angle. And so we want to solve this triangle, but again, we want to make sure that we look at what situation we're dealing with to know how many solutions there might be. There may not be any solutions. We might have a triangle here that really is not a triangle, okay? So the first thing I'm going to do is I want to solve for all of the angles. And the reason being is I want to know what the angle of these two are, because it looks like this is an obtuse angle here, and this is less than this, but there might be two triangles going on here. Okay, because A is less than B, so this side is less than this side. And I need to know, is this less than or greater than the altitude? Okay, because if it's greater than the altitude, then I have two possible solutions. Okay, and it does look like this is an obtuse angle here. Okay. And if it is an obtuse angle, then that will also tell me that I have two solutions. So let's see what we get first. So let's use the law of sines and solve for the angles. Now in this case here, if we had one of the other two angles, we could use the fact that the interior angles of a triangle add up to 180 degrees. We can't do that because we only have one angle. So that means we're going to have to use the law of sines to solve and approximate. And again, we'll approximate to 1/10 of a degree the other angles. Okay, so once we have one of the angles, then we can use the fact that the angles add up to 180 degrees to get the third angle. Okay, so let's start. So let's use sine A over 6. Oh, so sine 35 is equal to sine B over 8. Okay, that's the proportion we have to use. Okay, so now let's solve for sine B. So we'll solve for B. So we get sine B is equal to 8 sine 35 degrees divided by 30. And again, if I now here's the thing, I'm not going to do this. Now you can put this in your calculator and get an approximation. What I'm going to do is I'm going to take the inverse sine of both sides, because again, I'm looking for B. So I know if I take the inverse sine of both sides, I get B is equal to the sine inverse of what? This whole thing. So 8 sine 35 degrees divided by 60. And if I stick that in my calculator, what do I get? I get approximately 49.9 degrees. So let me verify that. So I'm going to stick this in my calculator. And so I'm going to get inverse sine of 8 times sine 35 divided by 6. And yes, I get 49.886 degrees. And so that's going to be, again, the same thing, 49.9 degrees. If I round to the nearest tenth of a degree, 49.9 degrees. Now, notice that this is less than 90 degrees, but our angle looks like it's bigger than 90 degrees. Okay, so this further tells me that, hey, I'm going to have a second triangle here. So how do I get the other triangle? How do I get this angle? Since this is an obtuse angle, it looks like it's greater than 90 degrees. How do I get the other angle? Well, this comes into what we were talking about before. Okay, so let me let me do this. Let me draw the other side of this. Okay, my drawing's notwithstanding, well, you'll get my point. So remember in the last example where I said, okay, in the case where we have the ambiguous case, we had this hinge, this rod and a hinge that can swing through. Well, one of the things that you also notice as this swings through is that it intersects like a pendulum, right? This side is fixed, is a fixed length. So think of it as a rod, a fixed rod that swings on this hinge. So as it swings through, it's going to intersect this side at the same angle. So we know that this angle has to be the same as this angle, and so this is an isosceles triangle. And by the way, we know it's an isosceles triangle because we know the length doesn't change, right? So as it swings through, it's going to intersect at the same angle, which gives us an isosceles triangle, which by the way means this angle and this angle has to be the same. And so if we know this is 49.9 degrees, which would be this angle, then we know this angle has to be the complementary angle. So we know that 180 degrees minus 49.9 degrees gives us the other angle, which is going to be 130.1, or excuse me, yeah, 130.1 degrees. And so that's the other angle. So we have this angle, but we also have this angle for B. Okay, now that's going to give us the solution to our two triangles because we do have two triangles. Okay, but this is the triangle we're solving for, so let's see what we get. Okay, now, or let's see. Let's see. Okay, so now, let's say, okay, so we know this is going to be 130.1. Oops. Okay, so 130.1 degrees. Now we can get C, right? All we have to do is add these together, which gives us what? This is going to give us 185.1, right? So if we add these two, we get 185.1, or excuse me, 165.1. 165.1 degrees, right? So if we add these two angles, and now if we subtract those two angles, or the sum of those two angles from 180 degrees, then we end up with 14.9 degrees. And so that's angle C. So you got the 14.9 degrees. So let's do triangle 1. So now let's solve for triangle 1. Triangle 1, we've got A is equal to 35 degrees, B is equal to approximately 130.1 degrees, and C is approximately 14.9 degrees. Okay, so now we've got two of the sides, so we've got A is equal to 6, B is equal to 8. And so now we can get C. Now let's use the sign to get C, right? So let's do sine A over A equals sine C over C. Now, this is going to give us sine 35 degrees over 6. And then equals sine of 14.9 degrees over C. Oops, did I erase that? C. And so now I'm going to flip these, right? So this is going to be equivalent to 6 over sine 35 degrees, which is equal to C over sine of 14.9 degrees. And then all I have to do is multiply both sides by sine of 14.9 degrees. And I end up with what? C is equal to 6 times sine of 14.9 degrees divided by sine of 35 degrees. And when I stick that on my calculator, I get what? I get an approximate, where is it? Approximate value of 2.7 degrees. Okay, so 2.7 degrees. Okay, so now, that's the first triangle, right? So that's this triangle. Now, let's go on to triangle 2, which we have most of it already solved, right? So now, we've got the 49, so we've got A. Okay, so we got this one. So I'm going to erase this. So again, make sure you take notes. So I'm going to erase this part because I got it all filled in the triangle anyway. Now, okay, so now the second triangle is this bigger triangle, if you will. Okay, so now let's do A, B, and C, and A, B, and C. Now A doesn't change. A is still 35 degrees. But B over here, right? B, if we swing over this way, B is 49.9 degrees. Okay, now we have to add these two and subtract from 180, right? So if we add these two here, what do we get? We get 84.9. So we get 84.9 degrees. We want to subtract that from 180 degrees, right? And what do we get? Well, in this case, we get 94.1 degrees, right? So if you subtract off, so if you subtract off 85, you get 90. Oh, 95.1. Made a mistake. 95.1. It's always double check. So if you round this 85 and you subtract off 85, that's going to give you 95. So then you add on, because you subtracted 1/10 too much, you get 95.1. Okay. Okay. So the answer. So for the last angle, angle C, this larger angle becomes 95.1, and that makes sense. So we're a little more than 90 degrees. So 95.1 degrees. And again, add these up, you should get 180 degrees, right? So if you add these two together, you get 50 plus 95, which is 145. 145 plus 35 is 180. So we're good. Now, A and B are still the same. So this is 6 and this is 8. Now, but C is going to be bigger. Okay, so now we got to solve for C. This is where the law of sines is going to come in. And so this is going to be what? We're going to use sine of 35 degrees over 6 is equal to what? Sine of C, which is now 95.1 over C. And again, I'm going to invert it. I'm going to invert both sides. So that's going to be 6 over sine 35 degrees is equal to C over sine of 95.1 degrees. And of course, if I solve for C, I get C is equal to 6 times sine of 95.1 degrees over sine of 35 degrees. And of course, I'm going to get C is approximately 10.4. And so now I have my other solution. So again, I've got two solutions. In this case. And that's it. Now, however, we're looking for the values for the triangle with an obtuse angle beta. So we can see then that this is going to be the solution that we're looking for, right? So for this particular case, even though there are two possible solutions, the solution in this example is going to be this one, okay? But you gotta be aware, because the reason why is because if you just would have went with your first answer from the calculator, right? Because your calculator will always give you the acute angle. But you can see that this is, from the picture, you can see that this looks like an obtuse angle. So that's why you got to be careful, because in this case there were two separate solutions, and this one up here is the correct solution. This one down here would have been the wrong solution. So again, just be careful when it comes to the problems, that you're reading the problem carefully, looking at the picture, and then so you're solving for the correct triangle. Take care.